Laurent, there is a problem with the CI. Can you take care of it? No worries, I'll take care of it. Great, thank you. For me, the concept of CI/CD is one of the best concepts from the DevOps culture, allowing you to automate a cycle of development effectively. Unfortunately, the best designs can carry burdens that can be difficult to circumvent. One of these burdens is the disparity between the local environment and the continuous integration environment. We do things differently locally compared to the CI platform, and over time this gap can even widen. When we need to evolve or simply repair a continuous integration pipeline, most of the time, we have to modify the code, push to a remote directory, and wait. It's long, it's tedious, and we re-execute unnecessary steps. And that's how we end up chaining commits until everything is perfect. Or not. To understand a little better, we should ask ourselves what makes up a CI/CD chain. There are essentially two parts. On the one hand, there is the lifecycle part of your chain. What I mean by that is when your remote source code directory will evolve, these solutions will trigger a series of actions. That is the second part that we could call run. The problem with modern CI/CD platforms is that they have provided us with these two aspects, but they have been strongly coupled. It is difficult to execute without changing the remote directory, which therefore leads to the problem that I've just mentioned. Even if the developer has all the good intentions in the world, he cannot simply launch identically beforehand. The actions will be executed when he pushes his code, for example. There are specific actions, like GitHub actions, which will run the workflow locally. The problem that comes with this solution is to add an even stronger dependency on the original tool, and adding dependencies is generally not great. In addition to this, there is an ever-increasing complexity of applications and infrastructures, and we must always be at the level of this complexity in the automation of integration and deployment. And good luck with trying to manage this complexity with YAML, for example. Anyway, who likes to write YAML? To compensate, we can make scripts, but it must be said that scripts remains relevant up to a certain level, and they can quickly become less maintainable. For the most motivated, you can also start designing plugins such as actions of GitHub Actions. But then we come back to the problem that I also mentioned earlier, such as being highly dependent on the platform for which we have writing these plugins. It's not too much of a surprise in this video that we're going to explore a tool that wants to relieve us of these burdens. We'll detail a minimum of its design, and we'll end up with a small demo. So the tool in question is Dagger. Dagger wants to remedy the virus problem that I mentioned earlier by focusing on replacing the execution part of your CIs. Dagger wants to unify local environments with continuous integration. The last time it wanted to unify two different environments, it was the containers, and in particular Docker, that showed up. Here again, Dagger will try to take advantage of containerization technology as much as possible. It is a coincidence that the founder of Dagger is the founder of Docker? I don't think so. Containers will be managed through Buildkit in particular. If you are a Docker user, Buildkit is the unsteroid version of the original Docker builder. Dagger will use Buildkit to execute each elementary step of your CIs in containers, and thus benefit from many advantages, such as cache, but also fine parallelization. For example, when you create a Docker image, individual steps can be cached, or multiple independent steps can be run concurrently. With Dagger, it's the stages of your pipeline that will benefit from it, and you won't have to think about it. Maybe you will ask why we don't use Buildkit directly in this case. What is the added value of Dagger? The Dagger engine will prevent you from declaring your steps one by thinking about the dependencies between them. Rather, the goal is to let you focus on creating your pipeline logic, and then let Dagger do the right thing when he needs to. One can imagine a puzzle. You will gather the pieces you need, which can be files, directories, binaries, but also instructions to execute. Once everything is ready, you will be able to pass it to Dagger, which will allow you to recover what was created during the executions. To be a little more precise, it will create what is called a DAG, Directed Acyclic Graph, a hierarchical operation graph that perfectly reflects the logic it received from the user. And concretely, how do we submit executions to Dagger? Originally, Dagger took the gamble of allowing a pipeline to be written in Q. Q is basically a superset of JSON that adds some functionality like control structures. So we write our Q file, we pass it to Dagger, which parses it and determines everything that should be executed. On paper, it works. However, Q is very rare and few tools have used it, which made the learning curve too high for Dagger users. Dagger listened and gave us a solution. But rather than choosing a new language, they said, let's make it work with all languages. How did it do it? They covered their engine with an API, in particular a GraphQL API. Why GraphQL? Do we not fall back into the same problem as Q? Not really. Unlike Q, resources and tools on GraphQL are legends on the internet, so it's not really comparable. GraphQL allows for being highly expressive, which allows easy creation of any execution logic to be sent to Dagger. There is virtually no limit to the creation of a GraphQL query. You will be able to fit whatever is necessary. And now that we have an API, we can use any language that has an implementation of a GraphQL client. And regardless of the language that we use, the same API and therefore the same engine, the execution will be identical, which makes it possible not to think of certain concerns such as the execution logs, the scaling of the infrastructure of execution, and monitoring. And finally, to further facilitate the adoption of Dagger, there are also SDKs for certain languages. This allows you to no longer have to worry about the GraphQL part when you are going to compose your pipelines and to focus on writing your continuous integration code. Here we go, let's get started. As I said, the main way for using Dagger is through their GraphQL API. And nothing is better than an online playground to start with. This is one of the examples of the type of GraphQL resources on the internet that allows you to approach technologies with complete peace of mind. With the example you can see what a GraphQL query looks like. And especially here in the context of Dagger, we distinguish this interlocking, this tree of execution. It is a succession of references to type fields. We start with the fields of the query type here. The field that is used is container. It will remind you that with Dagger everything happens in containers. And this field returns a container type from which I can continue to use other fields of this type. Here, from will indicate that I want a container based on a specific image. We specify it in arguments of this field, and we can continue to fill in other fields like with exec, which will indicate commands to execute in this container. When does it end? When we ask for a field that returns a base type like a string. To recap with this request, I asked Dagger to return the standard output of a curl command after installing it in an Alpine container, and we can see the result on the right. Of course, there is more to it that we can do. On the playground, you can directly explore the schema of the GraphQL API where you can find all the fields of all types, and thus be able to compose more complex queries. I'm going to look for a Git repo of a small application made in Go, and we're going to build the binary of this little piece of code. For my first request, I will use the Git field, which takes an URL as an argument, and that of my directory I will simply continue to build my request to list the files present on the main branch. Let's pass a second request, which will build our piece of code this time. What is a bit new here is the with directory field, which will therefore make it possible to integrate a folder into the execution container. I'm just going to stop for a little while on this field. First argument of this field is simply the path, and then in the directory argument you will have to give the ID of the directory. This will allow me to explain a small concept. It is that of the Dagger directory file container object IDs. These IDs will in fact represent the state of this object at a given moment. So here I need the ID of a directory that contains the files I need. I have this just above, but I'm just missing the ID field. I run the first query again, and I'm going to retrieve the ID to place it in my second query. This request will therefore run my build from the files of the previous request and the list of the files for me afterwards. We see the appearance of my little binary called Dagger demo. And for the last request, we'll just come and execute this binary. And as for the build request, I get the ID with the previous request. This time it's just the ID of the binary I need. And to complete the query, I had the execution of the binary. It's a binary that doesn't do much, just adds the two numbers, arguments, and display the results. So we execute the last query, and we have 2 + 2 = 5. There is an error. I believe that the author of this repo did not set up any CI. That's good, as I plan to talk about the Dagger SDK, since the playground must remain a taste tool. No, this was not planned at all. So I remind you that using a Dagger SDK essentially allows two things: not having to worry about the GraphQL side and being able to write your CI in a programming language. Here I will show you an example CI using the Go SDK. I use a tool called Mage, which allows me to write Go functions that I can easily execute in the form of target, as in a make file for those who know. So in a Makefile subdirectory, I have a main.go file, where we find three functions. We will start with the test function, which will execute the unit tests of my application. To prepare a Dagger execution environment, I use the Dagger connect method, which will do two things, such as check if there is a usual engine Dagger, and if there is none, an engine will be started. Then a GraphQL session is created, which can be used during the execution of my code. And now with your client variables, we'll be able to execute our steps. And the way we write our code is very similar to what we did earlier with the GraphQL queries. Types become objects and fields methods. For example, to use the file, I need to perform my unit tests. Here is no Git as I did with the playground, rather than the whole files are already present locally. I use the client.host.directory method suite, which will read my current folder. I even pass some options to exclude files that I don't need. Then I will build the same container where the unit test will be executed. I chain the methods that are not necessary for me. You'll notice I pass the work.dir variable to the with directory methods, which amounts to doing what I did on the playground, which was copying the ID of the object. You will agree that it is a bit more practical when done with code. Then just execute my mage test command, and I find the logs of the steps executed by the Dagger engine, and at the end, the output of my unit test, which is not good. I'm not going to insult you by showing you the correction of a function that adds 2 digits, but here's what it looks like when it's fixed. For the rest, that is to say, the build and run function, the architecture is the same. We prepare the session with the Dagger engine, and we execute the containers, taking care to communicate the necessary variables between the different requests. You may notice that some code blocks are duplicated here and there, although it could be refactored in the CI code for readability. This has no impact on the execution. Nothing is duplicated. If there are duplicates, the steps will be cached and will not be rerun. This allows us to focus on the logic of our pipeline without a big impact. I'll stop here for the overview of Dagger. The next step would be to integrate these executions into your platform to connect the lifecycle part of your directory and the run. I put the GitHub directory in the description if you want to reproduce this demo and any links that could be useful for you to start. I would also like to thank the people behind Dagger for their availability to help me get started with the tool, but also for proofreading the script. Don't hesitate to subscribe to this channel so you don't miss any videos. See you next time on Impulse.tv. Well, who's the bad guy who gave me this function 2 + 2 = 5? I'm hallucinating. Does he know it's his doing? Shh, let's not tell him anything.